Yeah. So hello everyone, this is Varish here and welcome to Acid, Bases and Salts Day 3. So in our previous videos we have seen with what are acids and what are bases. We have had a great understanding of weak acids, strong acids and all that stuff. So according to our chapter, which the name of our chapter is Acid, Bases and Salts. So we have dealt with acids, we have dealt with bases. Now our next stop should be salts, right? But currently it's not that, because I'm gonna explain another topic which is gonna be about indicators. So in our next video we'll deal with salts, but now I guess you have a clear understanding about what a base is and a water acid and what an acid is. So suppose there is this case that you are given some liquid. It is colorless. For example, let's take it's colorless, and you're given a liquid, and it's very harsh, so you cannot taste it to identify whether that it is acid or basic. So how will you know whether that liquid is going to be acidic or basic, so that you can use it for your various purposes? For such purposes we have indicators. Indicators are the substances which identify whether a substance is acidic or basic. So suppose you have a white liquid. Suppose even let's take water itself, okay? How do we find out whether it's acid or in base? Are we drinking an acid or are we drinking a base? So we drink it, but we do not find it to be sour, nor we find it to be bitter. So from that, and even when we test it by using these special substances called indicators, we get an idea that it is neutral. It is neither acidic nor basic. If it was too acidic or too basic, it was impossible for us to drink. So it is neither acidic nor basic. Water is neutral in nature. If you drink pure water, that's what I'm saying. So these indicators, there are many types of indicators. Now there are humans. We have identified various ways in which you can see whether that particular substance is going to be acidic or basic, and those and the substances which identify whether that substance is acidic or basic is known as an indicator. If you want an example, here is. Now let's deal with the classifications only, no example now. Okay, there are two types of indicators: olfactory indicators and visual indicators. Now let's go to olfactory indicators first. Olfactory indicators are the indicators which change their smell, which gain their smell or lose their smell. So olfactory indicators basically refer to smell and nose. So it is like it depends on the smell to identify whether that substance is acidic or basic. We won't go into very deep in olfactory indicators because we'll be learning in our higher grades, but for now let's understand that olfactory indicators are the indicators which deal with smell. So these indicators need to be indicators which have a really strong sense of smell. We can smell, so that they change their smell. Suppose let's take clove itself. It has a very strong smell, as we all know. So the clove, when it is put in that liquid, which is an acid or a base, it can change its smell into some different smell. Let it be a good smell or a bad smell. It can change its smell. It can gain a new type of smell, or it can even lose its natural smell. Even onion, which is there, even it has a strong smell. So even it can change the smell, gain or lose smell. So olfactory indicators are those type of indicators which either change, gain or lose their smell. Now comes the most important part, visual indicators. Now visual indicators are, according to me, they are more helpful than olfactory indicators, because olfactory indicators change their smell, but visual indicators, they just change their color and we can quickly identify whether it's going to be an acidic or basic substance. Let's see. They indicate a change in the appearance. So suppose you take that liquid. If that liquid is pink, if it is an acid, it might change into something. If it is a base, it might change into something. If it is colorless also, it might change. So it all varies. So some of the examples are litmus, turmeric, China rose, phenolphthalein, etc. Now let's deal with visual indicators in a very interesting way now. Okay, so with these visual indicators as natural or artificial, and as you all know, natural indicators are which nature gives us, and artificial which we make. It's very simple. So from the examples, let's see what we have. First is litmus. Now, in our very first chapter, nutrition in plants, we heard about symbiotic nutrition. If you didn't check the videos, go to our channel and view these videos. So there we discussed about symbiotic nutrition, and there we talked about lichen, a symbiotic association between a fungi and alga. The alga or the algae provides food, and the fungi provides water and shelter to the alga. Thus, they have a symbiotic relationship. So, from this lichen organism is what we get litmus. Now, this litmus can be in the form of a solution, or it can be in the form of strips of paper. So, from that lichen we extract it, and mostly it is packaged in whole end. And that's just a fact. Now coming to the main point, there were 3 solutions. All of them were colorless. There was solution A, solution B, and solution N. Suppose let's take it an example. Solution A, and we got strips of litmus paper, which was there. Now these strips can be in blue color and in yellow color. Okay. So let's go. First, there were 6 papers, 3 blue papers and 3 red papers. So first solution was the A solution. It was colorless. So when the red paper was dipped in the A solution, it didn't change. It was red color only. It didn't change. Okay, next what was, they brought a blue color paper and they dipped. What happened? This blue color paper turned into red. So from this we understand that acid turns blue litmus red. It's again in litmus. So basically it can be represented as abracadabra. Acid turns blue A, acid turns B, blue red, R, A, B, R. So that's where we get it. So first thing is, when there is a litmus paper, blue litmus paper turns into red. So acid changes into red color, a very strong, dangerous red color. Next is the B solution. Now what happened was, the blue paper was dipped in the B solution. It remained blue only. And when the red paper was dipped, it turned into blue. So from this we understand that bases turn red litmus blue, or bases turn blue in litmus. Now there was the solution N. And then we brought the litmus paper, the red litmus paper, we dipped it and it remained red. Okay. Next, we brought the blue litmus paper and dipped it, and it remained blue. So there is no change in color. So that's why it's neutral. So in acid, it changes into red, in bases blue, and in neutral, it's no color. Next, turmeric. Turmeric in acid, it changes into yellow. In neutral, it's no color. Now base changes into an interesting red. Now turmeric is basically in yellow color. So acid, we won't find a major difference, but in base it completely turns into a very dark red. Now you might have observed this. Suppose there is a white shirt, clean white shirt, but while preparing some food or while eating, there was a turmeric stain on your shirt, and while washing it with detergent, it turns into red color, because the detergent, which is a base, is coming in contact with the turmeric, and the turmeric changes the base into red. So that is why it has changed. So in turmeric, acid to yellow, base to red, and neutral to no color. Next, China rose. Now I'll show the China rose in the next slide. So China rose in acid, it changes into dark pink, a very dark pink. So China rose, you need a solution of the China rose which is prepared. So when an acid changes into dark pink, now for base to green color and neutral is no color. So China rose shows again a very good change in color. So dark pink and green, 2 different colors, and no color, it's colorless. So that's why we can see. Next, artificial indicators. Now we are going to only discuss about phenolphthalein. Now phenolphthalein, it's how you pronounce. Acid, it's colorless. Okay. base it turns into pink, and neutral it's colorless. So one problem with this thing is like, suppose you have an indicator, okay? Suppose you have a colorless solution, you have a colorless solution, and when we test it with phenolphthalein, if it is colorless, we cannot know whether it's going to be an acid or a neutral. So we generally use litmus for our purposes. So here are some of the indicators. This is turmeric, this one is litmus, this is a phenolphthalein indicator, and this is China rose, a good red color to see. So this was the topic of the day. We have dealt with acids, bases, and now indicators also. In the next video, we'll talk about salts, and I'll give you something like some problems which are going to be very, very simple on the basis of on the topic of indicators. So the problems will be like, suppose there is a solution, it changes blue litmus red. What is the nature of that solution? So these simple problems I will try to give you in the next videos. So hope you learn new something, you learn new, and thank you for watching my video. We'll continue the chapter in the next video. Until then, bye bye.